Let's stop that recording. I do want to tell you guys, I meant to upload this earlier. I've been, you don't need to hear this, I've been on Zoom basically since 6:30 this morning. So I did manage to get about half an hour in between Zoom meetings, and I made a quick little exponents practice with some polynomial division practice. There's a video up on YouTube now that I just put up, Math 90 Exponents and Polynomial Division Practice. I think that's what I called it. So that's up there now. I had done it earlier this morning, and then I forgot to get the upload started before I got on my Zoom meeting, and then I'm like, oh shit, so I just got it started. I don't think yeah, it's up there now. Math 90 Exponent and Polynomial Division Practice. Yeah. So that's up there for you guys. So I also, oh man, this is crazy. I think I wanted to put up here, our next quiz is Wednesday. I wanted to put up here what would have been the practice test for this kind of stuff, but I don't think I've done that yet. That would be a really good thing to put up there, huh? Let me see. Yeah, okay. So I need to do that still. So eventually I'll do that. So do you have any questions? The quiz this Wednesday is going to be 6-5, 6-6, 6-7. Those three sections. So that deals with polynomial division stuff, negative exponent stuff. We still have to finish out section 6-7. There's something called scientific notation that we haven't done yet. So we still need to do that. Do you guys have any questions from the end of chapter 7 stuff, so that, you know, just to be ready for that quiz?
I don't have a question, but in regards to that YouTube that you just posted, is there a sheet that's on Canvas that is in relation to this, or were you just going over?
No, most of it in fact, I think every one of them I just made up.
Okay.
There's no sheet. There is like I just said a minute ago, I have that practice test thing that I still need to put up on Canvas, and I'll see about getting some time to post solutions video. Yeah. Any other questions about anything? Okay. I did get a little further with homework, but I'm not having a lot to grade because very few people are turning it in. So please turn it in. That will help you out. It will help me out so that I can space out my grading. Don't turn it in the day before the final. That would be much appreciated. Let me pull up the book here. All right, so if you guys don't have any questions from the end of chapter 6, so that dealt with dividing monomials, maybe I'll do a quick example of that. And then dividing polynomials, which is our favorite topic yet. And then, of course, we got to finish up 6-7 today, which is negative exponents that I actually told you about before. And it's scientific notation, which was a different beast altogether. Whoa, let me see. Okay, so let me do this. Just to remind you guys, because this is going to be on the, oh great, I've set this up so I can't get back here. This will be on the quiz on Wednesday. Oh yeah, what was I going to do? All right, I'll figure it out. I'd rather stand. Here, let me get this. This is so awesome. I just got done with the Senate meeting, so I really didn't have any time to prep my little station here, but I'm going to let you in on my secret. Here, I'm going to put this up here. Come here, laptop. Pop. And now I can stand up here. Oh, thank God. All right. All right. Where's my poor little mouse, dude? Come here. All right, guys. So let's do a couple examples. So again, Just to remind you, the quiz Wednesday will be 6-5, 6-6, 6-7. I like it. Can you guys see that? Yes. Minimal glare. 6-5 is the easy division, right? Especially compared to dividing by a polynomial, a binomial. So 6-5 is a problem like this. You can do it, Jeff. Yeah, I like this. This is nice and evil. I like it. And it's not evil. I'm sorry. It's not too evil. Sorry. I know I'm blocking it. Hold on. So why is this one easier? This is an easier form of division because the bottom has how many terms? How many terms does the bottom have? Yes, one term, right? How could I tell that? Because terms are separated by addition and subtraction. There is no addition and subtraction. This is one term. Therefore, I am allowed to break this up. And then I have 3 problems. Where's that glare coming from? Is it you? I have no idea where that glare is coming from. Too bad. So I can, these are 3 problems. I can reduce each one of those, right? I think I know where it's coming from. I don't know. Is that any better? No. All right. Well, I have no idea where that's coming from. Is anybody not with me right now? Do you guys remember doing this? This is before we learned about the crazy long division thing. And somebody had a really good question. They said, why can't we just do this on that next section, Jeff? This is relatively easy because the bottom, this only works if the bottom is one term. That's the only time this works. So I can reduce this, right? Don't put 2 down here. This is 1/2. This is 1/2, right? So it'll be 1/2. How many K's are left? And where are they? Oh, Scheisse. I'm not close this meeting.
2 on the bottom?
Yes, right? 4 cancel. There's 2 left on the bottom. I like it. I like it a lot. Let me see here if I can do that.
So can we also write that as 2 on the top, but it would be negative? Is either or acceptable? Or does it have to be?
No, be careful. This is not the same thing as that, right?
Okay.
I don't know if that's what you mean. If I put it on the top, it would be 2 to the -1 power, right? Right? So I really want to make sure this is understood. Never, ever, ever has negative meant flip unless now it's in an exponent, right? I wish if I owed you $5, I wish that meant, no, you owe me 1/5 of a dollar. Ha, ha, ha. So a negative number doesn't mean flip. A negative exponent means flip. And the other thing with that is normally the last step is to make sure there's no negative powers. You want to flip any negative powers. That's kind of like a last step with them is you make the powers positive by flipping any that are negative. Let me stop there for a minute, you guys.
That's what I was asking about. So it is improper if it's a negative 2 exponent?
Improper, not wrong. It's just sort of like not reducing a fraction at the end. It's the same number, but it's just not proper. You're supposed to reduce it, right? Same idea. Here, what goes into 49 and 14? 7, right? So this would be 7/2. Is that cool? Divide both by 7. And then how many K's are left? Here I can just do 8 minus 6, right? When I divide like bases, I subtract the powers. So that would be K squared. Minus, what goes into both of these? Well, actually, 14 does. Believe it or not. 14 goes in 4 times. And then how many K's are left here? Anybody?
5.
Jason are trying to stand at the East Coast
Yes.
and put in a
And that'll be it. All right, so that's what I call the nice division. Right? When we first learned it, you might not have agreed with it, but now you definitely agree with me when you see the long division that we have to do for when the bottom is not a monomial. Please let this be relatively easy. It's just break it up and then reduce each piece. There are 3 separate problems I make it into. Okay, I like it. So not seeing any questions about, yes?
Why you put just one number, not like the 12 on the last one? The last one.
Well, what do you mean 12? Sorry.
Like here we put 7K over 2.
Because 14 did not go into 49 evenly, right? So I have to reduce 49 over 14. That can be divided by 7, and it becomes 7 over 2. Right?
Okay,
But
yes.
56 divided by 14 is 4.
Okay.
Yeah, that's why. That's all. Same thing we always do. Right?
Okay.
If I said reduce 80 over 8.
It's 10.
Yeah, but if I said reduce 80 over 6, what do you got, Jeff? 80 over 18.
I don't know.
I can divide both by 2, right? And that's as far as I can go. You see what I mean? That's all. That one I could not fully divide, but that one I can.
Okay.
All right, I like it. So just because they're sitting next to letters doesn't mean the numbers are going to act differently than they ever do. They're going to act the same as always.
Like you mean when we got the even number, we put just the number.
Oh, if it goes in evenly, yeah, of course, like always.
Yeah. Okay.
So each of these, if I just took the K's away, that problem, 7 over 14, acts the same way it always does. Just because I put more stuff on it doesn't mean anything changes about what I knew before.
Okay, I got
And I
it.
think that's a big problem with mathematics is every time we learn something new, I think there's some people that sort of feel like now we're learning everything from the beginning again. No. They have to work alongside everything we ever learned. Can't change what I've already learned. I mean, it's got to stay the same. Okay. I'm going to take this away. Have you guys, maybe I'll keep this up for a minute. Somebody just came in. So just to remind you guys, I do have a video up on YouTube. It's got some exponential examples, and it's got some long division of polynomial example, right? I think I just put one up there. That's all I had time to do in between meetings this morning. So you can go watch that. Does anybody want another long division example right now? It's fine if you do. Does anybody?
Yes.
Yes? Okay. So let's try, let me see where it's going to work the best. I guess this will work. X minus 4 into, this could get tricky, Jeff. Oh well. 5x squared. I'm trying to think ahead a little bit. Oh yeah, all right. Let's do minus 20x plus 11. Oh, this is interesting. Oh, this might be a little too interesting. I don't know. We'll find out. I made this more interesting than I meant to. So what's the first step here? Anybody? Anybody? What's the first step here, guys?
See how many times x goes into 5x squared.
Look at the first pieces here. And I feel like there are many of you that don't believe me, even though I've shown you multiple examples. That's exactly what we do if there were numbers. That's exactly what we do. We look at the first part. X times what is 5x squared? Well, I need a 5. And how many x's?
X.
And one more x, right?
Yes.
5 to make a 5 and another x to make x squared. I like it. So 5x times x, amazingly enough, is 5x squared. Of course it is, because that's where that came from. It's what made this. And then 5x times negative 4 is negative 20x. And then what do I do?
Change the sign.
Yeah, change the signs. And again, that's the exact same thing we do in normal long division, right? Long division of numbers. It's exactly the same thing that we do. Combine. Now what happens here?
It cancels.
Cancels. So I bring down the 11. Let me see if you guys get this. Normally it does not cancel, right? But here it did. Does x go into 11? Is x times something 11?
It'd be 11 over x minus
Yes.
4.
And really, now watch. All right, let's see. Something freaky coming your way. What is x minus 4 times 11 over x minus 4? What is x minus 4 times 11 over x minus 4? What happens to the x minus 4s?
11.
Something just happened. So that times this is that. Do you guys know? That's one reason why we put 11 over this, because that's what I multiply this by to get this. That's actually the same thing. But anyway, that might be too far. That one was a little weird because that middle term canceled too. I just had less work to do. How do I know when I'm done doing this kind of thing, right? How do I know when I'm done? When what's left has fewer x's than what's here. That's when I know I'm done. Otherwise, you might go forever and become insane. Okay. So I've got many examples of that in the last lecture or two and in the thing I put up on the YouTubes today. Any questions on that one? Okay. All right. So anything else from those sections before we get into scientific notation stuff? That's the last piece of that last section we got to do. So let me ask you this. I'm not seeing any questions. How many of you guys have heard of scientific notation? Somebody come in? No. Use a better color or green. Has anybody click the yes button if you have heard of, holy crap, I lost all my markers. If you've heard of scientific notation. This is the bad part about this. Everybody just, there they are. 4 people, okay, all right. Earthquake, okay, stop. So let's talk about this real quick. What is going on with you? Okay, all right. So now watch this. The motivation is this. Let's say I wanted to write this number. All right, let's say I just did, yay. But let's say you had to write that over and over and over and several times. Don't you want a shortcut way to write that? The most important part of this problem is sort of how many zeros there are, but it actually goes further than that, right? I'm sorry, somebody's got, you guys, I don't know. People's got weird things happening on their videos. So I'm going to do that problem in a minute. I want to do some smaller problems just to get the idea. All right, so here's one problem. how could I rewrite 4,000, for example? I could rewrite 4,000 as 4 times 1,000. Isn't that amazing, kids? And how can I rewrite 1,000? What's a more concise way to write 1,000? How many tens would multiply to become 1,000?
2.
10 times 1,000?
True. How many tens though? 10 times 10 is 100. Times 10 is 1,000. Right? There'd be 3 tens. And something extra cool is how many zeros are there in 1,000?
Yeah, that's right. 3.
Yeah, you got it, Anna. I'm with you. Or that's Youngsha. 4 times 10 to the 3rd power. So very often in astronomy, we say that star is roughly 10 to the 5th kilometers away. Because that's the most important thing, is relatively how big is something. So that number versus that number. Visually, it's hard to tell the difference. But if you wrote it like this, you could see a different power. It would tell you relatively how big of a number it is. This is on the order of 1,000. 3 zeros. Right? Okay, maybe. Notice this. Where's the decimal in the original problem? It's right here. How many times do I have to move it so that there's no tens left? 3 times. What do I mean by no tens left? If I moved it right there, I've moved it twice, but that is the number 40. Isn't 40 4 tens? Doesn't it still have tens in it? So I, being as weird as I am, I love looking at scientific notation as, get this is some weird shit, as a tens vampire. It tries to suck all the tens out of something and then it puts it over here, right? So I guess it doesn't really eat it. I don't know, it's just some weird vampire 10 collector. How's that sound? No? Okay. It's all weird, too bad. So watch this. So what about 11,300 then, sort of getting in that direction? Where's the decimal? Now we know the shortcut. Where's the decimal? Here. How many times do I have to move it until there's one number in front of the decimal? 1, 2, 3, 4. So that would be 1.13 times 10 to the 4th. Maybe, okay. And again, if you did this, if you multiplied this by 10 4 times, it will grow to be this number. So this isn't just another like symbolic way. No, it's actually a problem that works out to be this number. So what about small numbers? What about 0.004? Let's kind of tackle it like I did up here. How do you rewrite this as a fraction? What place is this in? Who remembers?
-3.
No. Don't jump ahead. I didn't say a damn thing about scientific notation. How do you rewrite this as a fraction?
4,000. 4
Yes.
and under 1,000.
Oh, yes. There you go. So 4 over 1,000, right? It's 4 thousandths, tenths, hundredths, thousandths, right? So isn't that 4 over 10 cubed?
3.
Become a 3, right? And then the final thing is, I want scientific notation to have the same format. I want it to look like this. So if I brought those 3 tens up, I'm going to make them unhappy. They like it down here. If I force them up, they're going to become negative. So I really want this to make sense. If I multiply by a bunch of tens, aren't I going to get bigger? Yeah. If I multiply by 10 to a negative power, that actually is dividing by 10, because doesn't 10 to a negative power mean over 10 then, dividing? So if I do this, I'm going to get smaller, smaller, smaller. That's why negative powers mean small numbers. Positive powers mean big numbers. Maybe. Okay. So let's do a couple more examples. So let's do this one up here, this big ass number here. I'm going to erase all this here. Oh, one more thing. How many places do I have to move this so that it's got one number in front of it? 1, 2, 3. That's where that 3 is coming from. Why is it negative? Because this is a small number. So it's got to be divided by 10 multiple times to become this small. So all of this is a shorthand way of writing these big ass numbers or small ass numbers, right? We don't discriminate against ass size. All right, so, oh shit, I just erased it. Oh crap. Here, I'll make another example. So what about this here? I can't remember exactly what it was. I think this is what it was. So the shortcut, I know the power is going to be, is the power on this scientific notation going to be positive or negative?
Positive.
Yes, because this is a big ass number. It's bigger than 10. Right? If it's smaller than 1, if it's point something, the power will be negative. And it's just because a negative power means you're actually dividing. And that's what's making it get smaller. So if I count, here's my decimal to start with, right? It's understood to be there. 3, 6, 9, 10. You always want to move it until there's one number in front of the decimal. So I'd move the decimal 3, 6, 9, 10. So it'll be 1.13 times 10 to the 10th. So sure enough, if you multiply 1.13 times 10 times, it will grow to be this. So that is a problem that works out to be this. Notice also, I kind of snuck this in, but this is the one place we still use X to mean multiplication. It's just a part of scientific notation. It's the last place we do that. Okay. I like it. Let's try another one. Is the power going to be negative or positive?
Negative.
Yes, because it's less than 1. It's a small number. So now you just got to figure out how many times do I have to move the decimal till it has the 8 in front of it, and that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 8.9 times 10 to the negative 9. So this just means the decimal would have to go back 9 times to become what the actual number is, right? So if you're talking about chemistry or physics, you could be talking about distances between electrons this small or something, right? So you want to be able to, or if you're talking about astronomy, you could be talking about distances between stars, huge magnitudes of numbers. So you want a quick way to write this instead of writing all those damn zeros out. Okay. So what about going the other way? What I mean by that is, what if I start with, sorry? Is everybody all right? Okay. What if I start with 4.8 times 10 to the 7th? And I want you to write that as a regular number, not in scientific notation. Will this become a big or a small number?
Big.
It will become a big ass number, right? Because it's a positive exponent. How many times do I move the decimal place?
7 times.
7 times. So this will be for once to get around the 8, once, and then I got to do 6 more times. 1, 2, 3, 4, 5, 6. So this number, right, 48 million, can be written as 4.8 times 10 to the 7th. Okay, maybe. So then what about this? That's a 3. I cannot do 3. Times 10 to the negative 5th. I like it. Thank you. And again, this is kind of nice. This is us saying, okay, math, you're freaky and all that shit, but how can you really help me? And math is like, all right, I could be helpful. You don't want to write all those zeros? Here's a way you can write it. Do you like that? Maybe. All right. So how do this is obviously going to become small. So when I was taught this, it was told if it's positive, you move to the right. If it's negative, you move to the left. And I always sucked at right and left. So I like negative is small. So it's going to move that way. Whatever that way is, it's going to make this small. So watch, this is kind of cool. It's got to move 5 times backwards. So once to get around the 3 and then 4 more times, right? So it'll be 1, 2, 3, 4, and then 3, 2, 5, because it went once, 2, 3, 4, 5. So the really cool thing about negative powers is whatever it is, the number zeros in front will be 1 less, because you have to move once to get around the number, and then the rest of the movements are going to be zeros. So if I had 7.02 times 10 to the negative 11ths, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 702. Because I'd have to take it and move back 11 once, and then back 10 more, and that's what it says to do. So as a physicist, because not only am I a mathematician, but I'm also a physicist, when I see, I don't even care about that part of the problem to me. I care about this. That tells me, 70 versus this is a huge difference. So I really, mostly we care about this kind of thing. What about, is it on the order of 1,000, a million, a millionths, 1,000th, right? What's it on the order of? That's the important part. Okay, maybe. Let me see what's going on over here. Okay. So anything about those? Here, let me give you a couple to try on your own. And then we might look ahead a little bit because we're insane. What day is it? What year is it? I don't know anymore. 20th? Oh, it's 420. Watch out. So you guys try these two. So convert to scientific notation. What do you got, Jeff? All right, do those two. Shit, put that up there. Jimmy. All right. Let me see. Let me block it for everybody. Ha 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 ha. Oh. All right. So this is one of those situations where you either get it and you can do it pretty quickly, or you have no idea. So it doesn't matter how much time I give you. I'm hoping most of us are in the first camp. So you should be done with the first one by now. On the first one, will it be negative or positive the power?
First one like negative.
First one's going to be negative. I like it because it's very small.
0.3 x 10 minus 5.
Not 0.3.
Yes.
No.
No.
Definitely not. You got to move it 1, 2, 3, 4, 5. You see how it ends right there?
Okay.
You always have to move it until there's one digit in front of the decimal place. So I agree with the 5 part, but then that would be 3.
Okay, I got it. I got the same number, but I put that point before 3.
Oh, I see. You got to be careful because that point's got to move all the way behind that 3.
Okay, I got it.
Okay.
I got it.
Oh, shit. I just muted you. Oh, shit. I just said shit. Oh, well. Thankfully, I don't get monetized. Hopefully, y'all see that. Because, again, if I stopped at 0.3, 0.3 is 3/10. See how it still has a 10 in it? The whole purpose of this is to suck all the 10s out of it and put them all over here. And so I should be left with a number between 1 and 9, right? Okay. So what about this guy? It's obviously going to be a positive power. And it's kind of nice. I got these grouped 3, 6, 9, 12. So it'll be 4.58 times 10 to the 12. Is that all right? You guys good out there? Anybody not good out there on this stuff here? Are you all right? All right.
I don't get it yet, the last one.
It's the same as this one. So this one, it was a 5. It was a 5 because you had to move it 1, 2, 3, 4, 5, right? And it was negative because it came from a small number. Same idea here. How many times you have to move that decimal until it's behind the 4? 3, 6, 9, 12 times, right? And of course, I'm grouping 1, 2, 3, 4, 5. Why would I do all that shit? 3, 6, 9, 12. So I've got to move the decimal 12 times so it can come from there all the way over there. Okay, maybe. So this is sort of like a blueprint. How do I build this number? Well, you start with 458, but then you move the decimal 12 times. So it's sort of like a rule how to make this number is another way to think of it, which is the first time I've ever looked at it that way, but that'll work too. No? Okay. Let's try it the other way. Let's try it the other way. So convert back to a number. Um, 3.7 times 10 to the negative 4. 1.49 times 10 to the 7th. So do those two. Oh gosh. $19,000, 1,200. All right, let me see. Let me come in here and do my thing. So this one, it's a negative power, which means move it back, make it small. So I got to move it back 4 times. I've got to move it once to get around the 3, and then 3 more times. once to get around the 3, and then 3 more times. So another way to do this is to put a bunch of zeros in front of 3, 7.
No, I got the
1,
same number.
2, 3, 4. What's happening out there? Okay. If you want to, put a bunch of zeros. But for negative powers, it's just so much easier to realize if that's a negative 4, there's going to be 3 zeros. There's always one less zero than that because that matches with 1, 2, 3, 4.
Yeah, I got the same number too.
Excellent. So what about this one? I've got to move it 7 times. I can do something similar here. I've got to move it twice to get around those 2. And then how many more times do I have to move it? 5 more. 1, 2, 3, 4, 5. Bam! 14 million. I like it. Hey, Mikey. Okay. Okay. How do you guys feel about scientific notation?
I sometimes I confuse with the last one, the positive.
So I really want everybody, everything I did on this problem, I did the exact thing on this problem. It's just I moved the other direction. So negative means make it small, move that way. Positive means make it big, move that way. So I just moved the decimal 1, 2, 3, 4, 5, 6, 7. 7 times. I just moved the decimal 7 times. That's it. This part tells me, because my number system is based on 10. I have no idea why it's based on 10. Yeah, so if we had 8 fingers, our number system would be based on 8. Let's not worry about what that would look like, because it ain't the reality. Since our number system is based on 10, this can be looked at as how many places do I move over? 7 over. So it started here, and then I just moved 7 over. That's all I did. Exactly what we did up here. Move 4 over, but back. Move 4 back, because it's a negative power. Okay. So, I mean, can you imagine, I'm not going to make you do this problem, but can you imagine if I had something like 2.7 times 10 to the 98th? Do you want to write that problem out? You're like, yeah, that sounds perfect for me. I'm so exceptionally bored. I need to write zeros forever. Holy scheisse, I don't know where your kid is. I'd much rather have a shorthand way to write this. So this would be 27 followed by 97 zeros. You guys understand? So the smaller the number of zeros, the less scientific notation kind of makes sense. It really is meant for these crazy big ass or crazy small ass numbers, right? I don't want to write that many zeros. So here's a nice way to just keep track of how many places back or forward it is. Okay, maybe. Do you guys get that? I mean, it's kind of nice to be able to see why we invented something. And hopefully you also want to see this is why we invented it, because math people are especially lazy. So of course we're going to make up something that doesn't need all that much work. My God. Okay. All right. I'm fine with ending things there for today, if that's all right. That'll be great for me, because I would really love some lunch. Let me think. I still need to put up there that practice. Please stop. Okay, thanks for that. You don't have to say that. Please make it stop, Jeff. Please, it's within your power. Where's my face? Hey. Yes, okay, I understand. I'm trying not to take that personal, but I will anyway. All right, guys, so that's enough for today.
Thank you.
You're welcome. I'll try to post that practice test kind of thing up there. Don't forget, so come ready, especially tomorrow, do as much out of chapter 6 homework as you can so you're ready to ask questions tomorrow for the quiz that's happening on Wednesday. Cool.
Bye-bye.
All right,
Thank
guys.
you.
See you.
Goodbye.